Hey, welcome again. This is a Think Out Loud session. We're going to try the biweekly contest 32. The recording will only be made available after the contest has been over so that we don't unintentionally help someone during the contest, which would not be legal, ethical. Right, so let's get started. We'll start from top to bottom. The kth missing positive number is what we're going to solve first. Let's have a look. All right. Yeah, so given an array ARR of positive integers sorted in a strictly increasing order and an integer k, find the kth positive integer that is missing from this array. Okay, 2, 3, 4, 2, 3, 4, 7, 11, and k equal to 5. The missing strictly increasing order and an integer k. Find the kth positive integer that is missing from this array. Okay, so the missing positive integers are 1, 5, 6, 8, 9, and the fifth missing. Okay. Alright, so we have this array, we sort it, we take the, uh, in terms of set notation, we subtract it from the set of natural numbers, and then we have to find the kth integer. Let's see the bounds. This is just 1000 and k is up to 1000, so this should be very simple. We can straight away do the brute force and that should work perfectly fine. So what we are gonna do is we can have an ordered set, but we don't need that. um, let's have so k is from 1 to 1000, right? So let's just have a dictionary. We don't even need a dictionary, so let's do this. Let's have a list of 1000 bools. So I'd have this is false into 1000, and this would be our check. All right. So the idea is that whatever integers we get, we'd mark them as visited. I'll do this as 1001 because we just ignore the zeroth index. That is easier to handle that way. So we're given an ARR now for E in ARR, check of E equal to true. Now for all the ones that we have marked it as true. We can instead do it the other way because it might seem more logical. Now, for all the true places that we have, we want to check the kth place, kth one, right? So we do it for I in range 1 to k plus 1 because we want the k plus first one. And what we do here is, right, so actually this index doesn't even matter so much. We'll just do this. Now we have an iteration index, so I put this as IND, so we start from the first one. Now we do so while check of IND is false, IND plus equal to 1. So basically what we're doing is we're finding a index which is true, and if it's false we're going to just keep ignoring it and keep incrementing IND. So after this time we'd have the next element which was not there in the list but there in the sequence of natural numbers, and I would increase, and we'd also increase IND plus equal to 1. So it would give us the first one, then the second one, then the third one, then so if k is 5, we want the fifth one. So in the first iteration we'd get the first one, then we'd move forward, then we'd get the next one, move forward. So at the end we'll get the fifth one, and then we'll move one forward from it. So IND minus 1 should be the answer in my opinion. So we want, yeah, we just want this. Let's just see if it runs with our sample test cases. our answer is 9, and yeah, it should have given 9. Let's just sum it and see if that works. Okay, index out of range. Oops. But this said that the array length at max is 1000 and each element is also less than 1000. So how can it go out of range? Okay, the kth element can be, so we can have this, that we have the first 1000 integers in the given array, but we still need the 1000th uh, integer that we've not already taken, so this can go up to 2000. So I'll just make this as 2001 and it should run perfectly, in my opinion. Let's see what happens. Oh, we got accepted. Thank you for sticking with us. Let's solve the next problem. I just break the video here just in case someone just wants to see this question and not the next one.